Hey guys, welcome back to my channel. In today's video, we are going to see how to find missing number in an array, right? So let's say an array is given to you. So given an array of size n minus 1 such that it contains distinct integers in range of 1 to n. Okay, so there are n minus 1 elements and 1 to n elements are there, right? So all the elements are unique, but you had to find that one missing number. You had to find that one missing number from 1 to n that is not present in this array, right? So let's say n is given 5. So ideally it should have 1 to 5 elements, right? So 1 should be there, 2 should be there, 3 should be there, right? So all the elements should be there. But bro, it is given that there is only n minus 1 element, right? Basically one element is missing. So we have to find that one element. So I'm just checking, 1 is there, yes 1 is there, 2 is there, yes 2 is there, 3 is there, yes 3 is there, 4 is there, no bro, 4 is not there, 5 is there, yes 5 is there, but 4 is not there, right? So the answer is 4. So similarly, let's say n is 10, so they are given some numbers between 1 to 10 and we just have to find that one missing number. So 1 is there, yes 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there, 7 is there, 8 is there, but 9 is not there. So 9 will be our answer. So the question is simple. So we just have to find that one missing number, right? So let's say n is given 5, right? So ideally it should have 1, 2, 3, 4, 5. But inside this array, let's say there are 4 elements and I have kept 1, 5, 2 and 4. But 3 is missing. So I have to find this 3, right? So the most brute force way that comes to my mind is, bro, what I'm going to do, I will go to all the elements from 1 to n, basically these elements, and I'm going to check for all these elements, for each of the element, whether that element is there in the array or not, right? And the array size is n minus 1. So for 1, I'm going and checking in all the indices. I found this one. So this is not the missing element. For 2, I'm going and checking in all the elements. 2 is there. For 3, I'm going and checking, but I didn't get 3. So 3 is the answer. But what I'm doing basically for n elements, I'm going and checking in this array that is having a size of n minus 1. So basically the time complexity will be n into n. For each n, I'm going to n elements and checking it. Basically n minus 1, but when we ignore the constants, it will be n square, right? And space, we are not taking any space here. So this is the brute force way that comes to my mind. Can we optimize it? I think we can. Let's see how. So if you have seen my last video, you might be remembering that we used set for what? To find an element in of one time complexity, right? So basically here also we are doing that only, right? We are finding whether one is there in this array or not. So we can store all the elements in some set, and then using this dot find inbuilt method, we will get to know whether one is there in the set or not. So we can use set also, or else you can use map also. You can mark all these elements as visited. Basically a map will be there, int comma bool. So for each int a bool will be assigned, and what I'm going to do, I'm going to iterate through this array and I'm going to mark all these elements as true. Let's say 1 is true, 5 is true, 2 is true, 4 is true, right? So in a visited map, I'm storing all this, and then I'm iterating through this and checking whether the element is marked as true or not, right? So yes, 1 is true, 2 is also true, 3 is not true. That means 3 is the missing number. So using set also or using map also, you can solve this problem. So in this, time complexity will be, you will be iterating through any one of these things, right? So of n will be the time complexity, and also you are using a space that is for set or map. So of n will be this space complexity, right? But what I'm saying, bro, try to improve more. Like, try to not use any space. So that's when we are going for the most optimized solutions, right? So there are two solutions. One is a formula based one. The second one is using XOR, right? So let's look into the first one. Is to basically find sum. Let's say n equal to 6. So 1, 2, 3, 4, 5, 6. These all are the elements, and I'm given the array. Let's say 1, 2, 6, 5, 3, right? So here 4 is missing. So how to find this 4? Can I take summation of all these elements and summation of all these elements and then get the difference? Can I do that? Can I say that the difference will be our answer? What I mean to say is, I'm saying, bro, I'm getting the summation of all these elements, that is 1 plus 2 plus 3 plus 4 plus 5 plus 6, right? From 1 to n, I'm getting the summation, and then I'm getting the summation of all the elements in the array. So this will be 1 plus 2 plus 6 plus 5 plus 3. And when I do this minus operation, what basically happens, this 1 and 1 will cancel each other, 2 and 2 will cancel each other, 3 and 3 will cancel each other, 5 and 5, 6 and 6. So 4 is left. So your answer will be 4, and that's the actual answer, right? Basically, summation of 1 to n minus summation of all the elements in ARR will give the answer. So in this, time complexity will be only O of n. You are actually iterating from 1 to n, and then here also O of n. So I can say O of 2n, and space complexity will be O of 1. Why? Because you are not using any space. But I am saying, bro, okay, O of 2n. Can I optimize this also? I can, although this doesn't matter much. I'm trying to, bro, get rid of this extra 2. So instead of traversing from 1 to n and get the sum, can I use the formula? Yes. So the formula is basically to find the summation of all n natural numbers. To find the summation of n natural numbers, right? So basically, so sum will be giving n into n minus 1 divided by 2. This will be giving summation from 1 to n, and then you are iterating from the starting index till the ending index, which will take O of n, and then getting the difference, right? So this operation takes only O of 1. So the overall time complexity will be O of 1 plus O of n, which is basically O of n. Okay, so this is one of the most optimized answer, but there is some other method also which we can implement. That is using XOR. But before that, let's look into the code. So this is the code, and here I am getting this summation of n natural numbers using this formula. Okay, it's n plus 1. I'm sorry. Here I have written n minus 1, right? So it is n plus 1. So yeah, n into n plus 1 divided by 2 will give the sum, and then I'm getting this summation of all the elements that are given to me, right? After that, I'm just taking the difference and I'm just returning the answer. So let's move on to the second optimized method, that is using XOR. So before getting into the intuition of XOR, let's understand the truth table of XOR, right? XOR truth table will be 1 1 will be giving 0, 0 0 will be giving 0, 1 0 will be giving 1, and 0 1 will be giving 1. Basically, if the bits are different, it will give true, right? Here also the bits are different, it is giving true. But if the bits are same, it will give false, right? So similarly, if I do something like 5 or 5, it will be 0. Why? 8 4 2 1 1 1. Okay, so 5 is 0 1 0 1. So when I do XOR with 0 1 0 1 1 1, these are same, 0 0 are same, 1 1 are same, 0 0 are same. So when they are same, the output will be 0, right? So 0 0 0 0 will be the output. Ultimately it will give 0, right? So when same elements are there, let's say A XOR A, right? When this operation is happening, answer will always be 0, right? And you have to keep one more thing in mind, that 0 1 will give 1, right? So 0 and some number 0 5 will give 5. Why? Because 0 0 0 0 0 1 0 1 different, so 1 1, rest are same, 0 0, this will be same as this. So 0 XOR A will always give this A. So these are the two properties that you need to keep in mind for solving it using XOR. I think you might be guessing like how to solve it. Again, 1 to n elements are there. Let's say n equals to 5. 1 2 3 4 5, and some elements are given. Let's say 1 2 3 5. 4 is not there. So what I'm going to do, I'm going to do the XOR operation for all these elements and for all these elements, and I'm XORing these two also. So what I'm going to do, I'm going to do XOR operation among all these elements. Basically it will be 1 XOR 2 XOR 3 XOR 4 XOR 5. Then take elements from here. So 1 XOR 2 XOR 3 XOR 5. What will be the answer? Same elements will be cancelled, right? So this one and this one will get cancelled. This 2 and this 2 will get cancelled. This 3 and this 3 will get cancelled. This 5 and this 5 will get cancelled. So the remainder 4 will be your answer. So that's how you solve it using XOR operation, right? But here also, bro, you are traversing here and then you are traversing here also. So it will be n plus n. But if I apply some brain, we can do it in n only. Although it doesn't matter still, because ultimately n plus n will be 2n, which will eventually give O of n. But still, if I want to remove this 2n in the array and get all these elements, you will be saying, bro, how? Because we'll be getting only this much. What about this? Bro, can we make use of indices? Yes. Say indices will be 0, 1, 2, 3. So can I do something like plus 1 in all the indices and get elements from 1 to 4? Right. So while getting these elements, I'm getting their index plus 1. Right. But we will only get from 1 till 4. Right? But 5 we won't be getting, right? We need 5 also, right? So we are taking n separately at the end. So that's how you are removing this 2 also, and time complexity will be of n and space complexity will be of 1. Right, so the code will look something like this. We are taking some variable XOR, which will basically contain XOR values, right? The size will be n minus 1, which is mentioned in the question. I'm iterating through this array, and then what I'm doing, okay, this will look something like XOR equals to XOR ARR of I XOR I plus 1, right? So what is this? What is ARR of I? It's basically the element, right? And I plus 1 will give the index value plus 1. Basically from 1 till n minus 1 I will get through this I, and the elements I will get using ARR of I. I'm taking the XOR of all these things and storing it again in XOR, and at the end I'm XORing that one part which is left. Then at the end XOR will be having the answer, which is basically that element which couldn't find a pair to cancel out, right? So we have seen so many approaches. I mean, the first approach was a brute force, The second approach was using map or set. The third approach was using some formula, and fourth approach was using XOR. So these two are the optimized approaches, because here you are taking a time complexity of n and space complexity of 1, and you are getting the answer, right? So I hope you got all these approaches. So I hope you enjoyed this video. If you like the video, hit the like button, subscribe to my channel. Until next time, see ya.